Now we're going to move into sequences. So sequences is you're really just looking at patterns. It's patterns that come in order. So here we have A sub 1, A sub 2, A sub 3, then A sub 4, A sub 5. And these are actually naming the term. So, you know, if your first term we usually call A sub 1, right? Your second one A sub 2, and so on. Right? We have two types of sequences. We have arithmetic and geometric. Arithmetic, we look for something that we call a common difference. Right? So for arithmetic, we add or subtract every time. So it might be like 1, 3, 5, 7, 9. Those are odd numbers, and we're adding 2 every time to get between odd numbers. All right? Arithmetic sequences end up being linear, right? Because they have a slope. You're going up the same amount every time. And then we have an explicit formula, which is going to look kind of weird. But our nth term, A sub n, equals our first term plus n minus 1 times d, our common difference. Okay, let me put a little arrow there. That's D. Okay, all this is kind of weird, kind of crazy. We're not really diving too deep into this, but you need to know that arithmetic sequences add or subtract something every time. What you add or subtract is your common difference. They're linear, and we need to know this explicit formula. This is what's going to help us figure out terms later on in our sequence, right? Like if I give you 3 numbers and I want you to tell me the 50th term, this is what we're going to use to figure that out. So make sure you have this written down somewhere. Okay, geometric sequences, all right, they have what we call a common ratio, right? So they, instead of adding and subtracting every time, you're multiplying by something every time. And technically it's multiplying or dividing, right? But we talked about with our exponential, if you divide by a number, it's the same as multiplying by 1 over that number. All right? These end up being exponential. So they're either going to get super big, super fast, or they're going to get super small, super fast. All right? So we are going to use an explicit formula for these two. And that's A sub n equals our first term, A sub 1, times our common ratio r. And this one's going to look a little different. It's always going to be raised to the n minus 1. Okay, so both of our equations have this n minus 1 in there, right? And both of our equations have our A sub 1, our first term, right? And then this is our r. Okay, and then it's just a matter of, you know, adding the first term times the difference, or if we are multiplying and then raising our ratio to that power. So again, make sure you have these two written down. The types of examples we're going to see with our sequences, okay, you have to, oh, I lost it. There we go. You have to determine if your sequence is arithmetic or geometric. Right? So that's the easier type of question. You're just looking to see if you're adding every time or you're multiplying every time. And if we are, find the difference or the ratio. Or if you're not doing either one of those things, then it's going to be neither. So it's really determined arithmetic, geometric, or neither, if that's the case. And we're just looking by what we go up and down by in our sequences. So these are our sequences. You're always going to be given numbers written with commas in between. So our first sequence, we start at 40. That's our A sub 1. Right? We don't need that for right now, but just make note of that. Then we go to 43, 46, 49, 52. Whenever I'm trying to figure out if it's arithmetic or geometric, I always look for adding and subtracting first, because that's way easier than multiplying and dividing. Right? So to go from 40 to 43, let me change colors here, I can add 3. Right? To go 43 to 46, I can add 3. 46 to 49, I can add 3. And then 49 to 52, I can add 3. So I have a sum of 3 to move up every single time. That means that this one's going to be arithmetic. And if it's arithmetic, it has a common difference. So my common difference is a positive 3. All right, for the next one, I'm going to start, now you might be able to see it quicker, but I'm going to show you kind of a thought process for if you can't just see it right off the bat. To go from 1 to 5, I would add 4. To go from 5 to 25, I would add 20. So right off the bat, not arithmetic because I'm not adding the same thing every time. So now I'm going to go to multiplying, right? So to go from, we'll write it up here. To go from 1 to 5, I can multiply by 5. 5 to 25, I can multiply by 5. 25 to 125. And then 125 to 625. So I'm multiplying by the same thing every time. That means this one's going to be geometric. And my my common ratio is a positive 5. Okay, so I start with adding and subtracting just because it's easy. And if it's, as soon as I get to something different, it's not going to be arithmetic. I'll try geometric. Okay, so for number 3, same start. To go from 1 to 3, can add 2. To go 3 to 6, I add 3. Automatically not geometric. To go from 1 to 3 multiplying, I would multiply by 3. To go from 3 to 6, I would multiply by 2. So this one's not geometric either. That means because I don't add or multiply by the same thing each time, it's going to be a neither. Okay, for the next one, right, I've got -4, positive 12, negative 36, positive, negative, positive, negative. As soon as you start switching positives and negatives, you know automatically it can't be arithmetic because there's no way I can add by the same number and go back and forth. So as soon as you have alternating signs, there's no way it can be arithmetic. So we're going to try geometric. Okay, to go from a -4 to a positive 12, I need to multiply by a -3. To go from 12 to negative 36, multiply by -3. Negative 36 to 108, multiply by -3. And then 108 to negative 324, multiply by -3. So then that means that this one is geometric. And my ratio, my common ratio, is a -3. All right, now if you're not sure, like if it started with bigger numbers, like if you didn't have the first two there and you had bigger numbers you're not familiar with, just like for exponentials, if you're looking for that ratio to see what the ratio is, you can divide to find it. So if I wasn't sure, I could say the second one divided by the first. So we could say 12 divided by a -4, which is, -3. Then I could do it again with the next set. So I could say -36 divided by 12. That's a -3. Right? So you can keep doing that if you need to and using your calculator to see if you have that, the same ratio every time you do this. Okay? Then for number 5, I'm going to start with arithmetic because I'm not switching signs. So we've got 0 to 3, add 3. 3 to 8, add 5. Definitely not arithmetic. Okay, then to go from 0 to 3, right, I can't do that. There's nothing I can multiply by 0 that would get me to 3, right, because 0 times anything is 0. So anytime you start with a 0 as your first term, can't be geometric. So this one's not arithmetic, it's not geometric, so that leaves me with neither. Okay, then our last one, fractions, gross. Okay, if it is a fraction, think about it as a decimal. Okay, 3 goes into 13 4 times, and that leaves you with 4 1/3, right? Which, we'll leave it as a third just because a third is an ugly decimal because it's repeating. It's 0.33333333. Okay, so then 3 into 14 becomes, 4 2/3. Then we have 5. And then 3 into 16 is 5 1/3. All right. So in other words, we have 4.3333333333, 4.66666666, 5.33333333. Okay. So to go from 4 to 4 1/3, I can add a third. To go from 4 1/3 to 4 2/3, I can add a third. 4 2/3 to 5, I can add a third. And then 5 to 5 1/3, I can add a third. Or if you're looking at decimals, I'm adding 1.33333333 every single time. So I'm adding the same thing, which means this one's going to be geometric. Oh, no. What am I thinking? Not geometric. Arithmetic. I'm running out of room now. Gross. Okay, arithmetic, and my common difference is a positive 1/3. All right, so a couple things really quick about your common difference and your common ratio. If I'm dividing, okay, I don't even know where to write this. We'll come up here. Okay, if I'm dividing by a number, my ratio is going to be a fraction. So it's going to be 1 over whatever number I'm dividing by. All right, so it's always what you multiply by, so it's really going to be multiplying by a fraction. If I'm subtracting, my common difference is a negative number. So if I was going, let's see if we go back to that first one. If I was going down by 3 every time, it's going to be a negative 3. Okay, so I didn't have those examples on there. Probably should have put them on here, but wasn't thinking. So just so you're aware, if it's dividing, it's really a fraction, just like we talked about with our exponential functions. And if you are subtracting, it's going to be a negative common difference. Okay, last part, we want to find the 21st term of this arithmetic sequence. Okay, now 21's not the worst. You could figure out your common difference, and you could write out all 21 terms. That's going to take a little while, especially if they're bigger numbers, or if I were to ask you for the 104th term, okay? It's going to take you a long time. So what we're going to do to figure these out is use that explicit formula, okay? So I'm going to jot that down up here just so we're reminded. That explicit formula says that our nth term, so in this case I'd be looking for a sub 21, right, our 21st term, equals our first term plus n minus 1 times our common difference, right? It's not as bad as it seems. And get a different color, we'll go pink. So for all of these, I'm looking for a sub 21, right? Because I'm looking for my 21st term. So if I start to plug in, I'm going to use a sub 21, which means in this case, n equals 21. So a sub 21 equals a sub 1, which is my first term, so 2, plus n minus 1, so that's 21 minus 1, times my common difference. I got to come back here. Each time I'm adding 3. So my common difference is 3. So I'm going to put my 3 on the outside there. So I have 2 plus 21 minus 1 is 20 times 3. Okay, and I'll put that in parentheses, looks better. 20 times 3 is 60. And then 2 plus 60 is 63. So there's the 21st term. If I had kept adding those and getting all the way down to 21, that's what term it would be. All right, so it's really not that bad. It's just a matter of plugging in, so make sure you have this written down somewhere. Okay, for the second one, I got a sub 21 equals my first term, negative 6, plus, now for all 3 of these, n's going to be 21, just because that's the one I'm working with. It's not always 21. It's whatever term you're looking for, right? Whatever number's here is the number that you put here. Okay, so then 21 minus 1, and then my common difference, to go from negative 6 to negative 12, I'm subtracting 6. So I'm going to have a negative. Negative 6. All right, so that's negative 6, and again, 21 minus 1 is 20, times negative 6. 20 times negative 6 is negative 120, and then negative 6 minus 120, negative 126. All right, one more. Our 21st term is our first term plus n minus 1 times our common difference. So my common difference, to go from negative 191 to negative 391, I'm getting more negative, so I'm subtracting, I have a negative common difference, and that's going to be a negative 200. Whew, big number. Okay, so then I get negative 191, 21 minus 1 is 20, okay, and then times negative 200. Okay, let's see, negative 191 plus, so we got, oh, I'm going to get rid of that. We're going to have 20 times 200, it's going to be 4,000, it's going to be a negative 4,000. Okay, so I have a negative minus a number, which means I'm getting more negative. So I'm going to be at negative 4,191. All right, now, All this might sound crazy, might be, kind of overwhelmed, but all we're doing is plugging in to our formula here. Once you get this part written down, you can type that in the calculator and call it a day. Okay, all this extra work here is just mental math, me going through it, working it out in my head. But once you have the correct explicit formula filled in, type it on the calculator, get an answer, call it a day.